Hi, my name is Will Green, and this is my STEM capstone project, The Glove. The Glove is a specially designed glove for offensive and defensive linemen in the sport of American football and is used to help prevent soft tissue injuries. The problem statement is because finger injuries can be devastating to football players, particularly offensive and defensive linemen in their careers, I believe that a device needs to be made to help prevent these injuries during play. My personal attachment to this is I was an offensive and defensive lineman when I played football and constantly received finger jams and injuries of that sort, and I hated it, so I decided to design something that would help prevent these injuries. Also depicted, you can see Hall of Famer Anthony Munoz with his mangled pinky finger. I'm sure he would have enjoyed some extra support for that finger. My original plan was to create a full glove that would protect from a variety of soft tissue injuries. This later evolved into a series of separate fingers which would attach to a singular handpiece, which would help prevent hyperextensions. My first iteration was 3 pieces of cardboard scotch taped to my finger. These pieces overlapped to help add additional support to my joints when my finger pushed back in a hyperextending motion. My second iteration was a 3D printed version of my first with three 3D printed versions attached to my finger in an overlapping manner to add support to my joints. My third iteration was meant to mimic the finger's natural joints. Unfortunately, this design was far too bulky, and 4 of these on your hand would spread out the fingers too much and be uncomfortable. My final iteration was a rubber joint system that greatly decreased the width of my design, allowing it to sit on my finger much more comfortably and on all my fingers much more comfortably, and it also had a scissoring mechanism that added strength to my design. Further, it had string threaded through it, which was meant to be used to attach to my finger. I was planning on changing this to an elastic band. However, I was unable to do so due to school closing. For my testing, I hung an ever increasing amount of weight from my longest and shortest finger sections. By this I mean I took a design for my middle finger and hung weight from it, and a design for my classmate Amari's pinky finger. The point of this was to test different sizes and see how that affected the strength of my design. I did this in this manner to increase the impulse to a much greater level than would actually be seen on the field. The purpose of doing the test like this, it puts all the pieces under stress, not just the hard 3D printed pieces. After a certain point, my uh, rubber joints were pulled taut, meaning that they had to assist in carrying the load being applied to my fingers. Um, Additionally, this tests the pieces as a unit and not individually, simulating how they would be meant to function on the field. So, in doing this, I didn't want to test the individual pieces, as that was not as important as understanding how the pieces work together and how strong they were as a unit, as that is how they would work in the design and in actual field testing. My results were for a finger piece designed for my middle finger, which is about 11 centimeters long. I managed to break it after adding 2.55 kilograms of weight, which totaled to a torque force of around 350 newtons. For a finger piece designed for Amari's pinky finger, which is about 7 centimeters long, I managed to break it after adding 3.6 kilograms, which totaled to about 260 newtons of force. My design for this 3D printed or hard pieces is incredibly strong, with only minor deformations of pieces made of a very basic material. I did not use the strongest material available to me, as it is quite expensive, so I decided to go with a lower end piece, but I was still incredibly satisfied with the results, and with higher end material, my design would be even stronger. My rubber joints need to be strengthened, and the best way to do this is to simply find a stronger rubber. Uh, Eventually, after my rubber joints were pulled taut, they snapped, which caused the pieces to disconnect, which destroyed my design, and that was my failure point. So I need to find a stronger material to make my rubber joints out of, which will drastically increase the strength of my design. My name is Will Green. This has been my STEM capstone project, The Glove. Thank you for watching.